In this tutorial, we're going to be building a weather station using the Arduino Nano BLE Sense board, and we are going to be able to predict whether it's going to rain or not. In the previous tutorial, we built a speech recognition system using Arduino Nano BLE Sense and Edge Impulse. What we did was that we built the model on Edge Impulse and then we deployed it to our TinyML board. That's the Nano BLE Sense board. But in this tutorial, we're going to be doing everything from scratch. We're going to be building the model on Goofle Colab using Tensorflow, and then we're going to be deploying the model on our Nano BLE Sense board. So let me give you a quick walkthrough of what we're going to be doing throughout the course of this tutorial. The first thing we do is that we are going to grab the data from worldweatheronline.com. After that, we are going to prepare the data set. Then we are going to train the model using TensorFlow. Then we are going to evaluate the model for performance. Once we are satisfied with the performance of the model, we are going to convert it to a Tensorflow Lite model so that it will be able to run on a very small microcontroller like the TinyML board. After that, we are going to be deploying the model on our Nano BLE Sense board for on-device inferencing. This might be a somehow long tutorial, but it's going to really worth your time, so take time to walk through to the end. Most people do have problem taking temperature readings using the Arduino Nano BLE Sense board. During the course of this tutorial, I'm going to show you a very good walkthrough around that so that you'll be able to take temperature reading using the Nano BLE Sense board. If you have not subscribed to this channel, please kindly do so by clicking on the subscribe button below. It really means a lot to me and I really appreciate it. So let's get straight into the tutorial. To get started, the first thing you want to do is to open an account with worldweatheronline.com. So we're going to be using an API from worldweatheronline.com for us to be able to grab our datasets. So just come to worldweatheronline.com/developer. So once you are here, it's not free. So but you have this 30 days free trial, after which if you want to continue using it, you have to subscribe. So what we just register for in this case is just the 30 days free trial. So once I click on this, try for 30 days. So I already registered an account. If this is your first time, just feel free to create an account. So I'm going to log in now, email and my password. Oh, I want to log in. So click on login. Yeah. So I just click login then. So here I am in my dashboard. You can see it shows me the key here and it's ending on 7th of August and the likes. So everything I want to do, I have to come and grab this key for me to be able to make API calls to grab the data. So after creating an account and then you're able to access the dashboard, the next thing you have to do is to go to Google Colab. So just open a new tab and search for Colab. I'm sure you should have a Colab account. So colab.research.google.com. And if it's your first time of using Colab, it's not difficult to use at all. It's very simple. So this is the interface you'll be presented with first. To create a new notebook, you can just come to new notebook. And then you have something that looks like Jupyter Lab, but in the cloud. One good thing about Google Colab is that you have access to resources that you might not be able to get on a normal day if you're using your natural computer. So just to try this out, you can put a simple print statement. So let me just put print hello or something. And then to run it, just like Jupyter Notebook, just put Shift Enter. And then we have hello. Though you can see now it has not printed out because if you look here, it's still connecting to the CPU. So now it's fully connected. So we have hello printed. So in case you want to run some powerful machine learning processes, you can just come here and then you can change runtime type. Currently I'm using a CPU. So if I click here, you can see I have a CPU being used. So in case I want to change to GPU, I just have to select this and I'll be done. But in this case, I don't really need a GPU. I'll just stick to CPU. So I already create the script for this project. So everything we need is already created. So let me just walk you through everything that I did. And I'm going to make the code available in the description below. So if I click on File, Open Notebook. Yeah, I call it Nano 33 TensorFlow Lite Micro Test. This, and then here we have everything that we need. So I'm going to walk you through and then explaining every cell of the code. So the first thing you have to do is to download the module that we need for us to be able to grab the data from worldweatheronline.com. So here we have our dashboard for worldweatheronline.com. We need the Python module to be able to grab the data and then process it in our notebook. And what you need to do is just to install the module into your Colab. You can just use pip install wwo-east. And even if you're not using Google Colab, this will also work fine if you're using your own local computers if you're using your own local computer, CPU, or your Jupyter notebook running locally on your computer. So I'll just install this. One thing about Colab is that anytime you are running this lab, you have to keep on doing this over and over again. It's not saved permanently, unlike your normal computer. So it said successfully installed WWO. So once we have this installed, we are going to import the module here. So from WWO import retrieve install data, and then once I run this, I have it run. So we need to get all these modules into our environment. So importing CSV data time. We are going to be seeing how to use each of these as we progress. So I'm going to use OS, Pandas, Seaborn, sklearn, TensorFlow also, and we're going to be using some NumPy functions and some linear regression functions. We have sklearn, model selection, we have TensorFlow, Keras, and likes. So I'll just run this, and then this is done importing. So now this is a very important part. This is where we are going to be grabbing the data from World Weather Online. So here we have the frequencies one. Frequency one means it's going to grab the data day by day. If it's 3, it's going to be 3 days interval. So API key is just what I have here. That's my API key here. So again, I'm going to just copy it here. Just you have to create your own account and use your API key. And then with location, I'm using Lagos. We are in raining season in Nigeria now, so I'm using Lagos. And then we are going to be predicting whether it's going to rain or not. So we are going to create a data frame of weather. So what this is going to be taking will be our API key, the location list, which is what we part here. If you want to take for multiple locations, you just have to put comma and then insert the other location that you want. So this will be the start date and the end date. So we are going to be grabbing from, this can be as much as you can, but I'm going to be grabbing from January 2015 to December 2020. I can bring it up to 2024 or anyhow. This is just for a test. So the frequency is what we pass here, which is 1 day interval. And this is the location label, export stored df is going to be true. Yeah. So, but then if I try to run this, I'm going to run into an error, and I'm going to be showing you how to solve this. So this error is actually due to a change in the pandas structure. If I come in here, so it says date time array got an unexpected keyword argument closed. So the only way we can solve this is if we come into the module that we downloaded and make some change. Yeah, if you come to this particular line 69, it says list month begin and then pd.date range, start date, end date, frequency is equal to ms, and closed equal to right. So pandas no more uses closed in grabbing in date range. It now uses inclusive. So I just have to come here, click on this. It's going to open it in a separate tab, and I'm going to change this from closed to inclusive. So this is due to a change in the pandas structure. So from closed to inclusive, there's one more we have to do. So you change this in line 69. You also have to come down to line 74 and make the change. So here we just change to inclusive. So save this and then you can close it. So once you are done saving and it's closed, we have to restart this environment. So come to runtime and restart session. Yes. So here it says restarting. Once that's restarted, yeah, we have seen that's restarted. And then you don't have to do the install again. If you do the install again, you have to do this over and over again. So no need for installing again. Just run this again. So again, I'm going to run, and then so this should work now. So you see it works, and then it's currently retrieving data for Lagos starting from 2015. So this is going to keep running until it reaches 2020. So I've just paused this now, and once it's done, we continue. With that, we are done grabbing the data from worldweatheronline.com. So the next thing we are doing in this cell is to change those things that we have into a list. So here we have df weather. So here I'm grabbing the temperature, I'm grabbing the humidity, and I'm grabbing the precipitation. So precipitation is also the same thing as rainfall, and then I'm saving it into a list of temperature list, humidity list, and precipitation list. So if I run this, and then we can just check what is in df0. We should know that df0 contains all our data sets that we're looking for, and then this is everything. We have date time, max, min, and likes. So grabbing the temperature C, we are saving it into T list, grabbing the humidity, we are saving it into H list, and grabbing the precipitation, we are saving it into P list. So that's just a simple debug to see what is going on. And if we do .info, this is a pandas function. It shows us what is inside our data sets. Here we can see that we are looking at a 52,608 rows of data, and we have all these variables being identified. We have the date time, minimum temperature, maximum temperature. So what we need, as I mentioned, is just the temperature, the humidity, and then the precipitation, which is the same thing as rainfall. So after that, we are running this cell. So this cell is basically to binarize our data set. We're going to do a simple plot, and then we're going to, it's just basically to show precipitation plotted against the humidity and then the rainfall. So if I run this, so we have this particular point that shows humidity on the vertical and then temperature on the horizontal, and then we have our precipitation data being plotted. So one thing we can note here is that when the rain usually falls when the temperature in Nigeria, we don't have very low temperature, so we can expect something around 22 to be at least a very good cool day. So we have 22 degrees Celsius, and you can see that the rain usually falls around 22 degrees Celsius and 30 degrees Celsius. Anything above 30, rain hardly falls. And the same thing with humidity. For rain to fall, the relative humidity has to be high. So we are looking at something above 50% up to 100%. So that's just a simple show of how our data looks like. So you can do the same plot for anything that you want to do. Yeah? And then we are generating a label, so you can just run this also. So one thing we are doing here is to create a subset of our data set so that we have much more data to train our model with. So we have temperature 0, temperature 1, temperature 2, humidity 0, 1, and 2. So what we are simply creating is, let me run this to show us what is happening here. So what we are simply creating is we are trying to extract this data from our main data set from what we have here. And then we are creating a subset of each of those points. Even though we have a single temperature from the original data set, we have a single humidity, but then we are trying to extract so that we have more data samples to train our model with. And then we are forming precipitation. So what we are doing here is that if you come back here, we have if precipitation is greater than 0.5, meaning that if the number of rainfall in millimeter is greater than 0.5, we should say that it actually rains. And if it's less than 0.5, we should say that it doesn't rain. And for that to be possible, temperature has to be greater than 22 and temperature has to be less than 30, which is in between this range. So we are simply, since our problem here is a classification problem, we are trying to form our targets. That's why the Y data set. So we're trying to create a target to know the decision boundary when what we are going to classify as rainfall and what we are going to classify as no rainfall, since we have a binary classification of just whether it's going to rain or not. And from our data set, what we have is just numbers showing the number of rain that fell in millimeter. So you have to be able to know whether it rains or not using those numbers. And that is what is simply happening here by attaching anything greater than 0.5 to be rainfall and anything less than that to be no rainfall. So we create a new data set, and yeah, it's just a simple debug to see what is going on. So now we have number of time that it rains to be 48,492 within this data set, that it doesn't rain. A number of time that it rains is 4,104. You can see that this variation is too much. Our number of rain to no rain is too much. So what we have to do is to find a way to balance our data sets. And here we are doing a simple balancing of data sets. If I run this, so we created a balanced data set. So what we did here, what is happening in this cell is that I'm trying to divide the number of time that it doesn't rain, so that it's going to balance up with the number of time that it rained, which is 4114. So if I run this once again, we are going to need this while deploying our model on the Arduino Nano, the 3 BLE Sense. So we need to get the mean and the standard deviation. We need to input this into our Arduino code. So that's why I have this simple from the original code where I have this copy mean that shows that you have to copy the standard deviation and the mean. So here you have the temperature and the humidity. So the mean of the temperature is 27, standard deviation is this, and the same thing for humidity too. So here we have to do a feature scaling. We have to scale our data sets using the different method that can be used in this case. But in this case, we are doing a simple feature scaling of using z-score. So if I run this and run this again, we see that there will be a change in our data set. Instead of ranging from what we have here 26, we now have everything turned to a very small number in between 0, and then the gap in between data sets is not much again. So yeah, simple encoder to hold encoded information, that's to hold yes and no. Here we have yes for when it rains and no for when it doesn't rain. So we need to work with numbers. So I'm going to change all the yes to 1 and all the no's to 0, and that is what is simply being done using this label encoder. So we can have all the no's to be 0 and then all the yes to be 1. So here we start our training. We split our data set into train, test, and validation. So after doing the splitting, we can create a model with Keras API. So to do that is just simply run this block of code. You can read more about this, and then we are going to use sigmoid function since we are looking at a logistic regression. So if I run this, so we have all these parameters for our model, and I can compile the model, and here I'm going to do the training. So once I discover is that running this in 20 different cycles brings us to a very good parameters W and B, so we don't need to keep on running over and over again. Even if you run up to 20, up to 30, it's going to be ending at the same point. So we can just leave the number of epochs to be 64, to be 20, and batch size is 64. And then just to plot a simple behavior of our model, so you can see the training and validation. So we have the original training set and the validation. So the training is in green, and then the validation is in blue. So we can see this model quite performs very well. Here I save the model as precipitation forecast. So saving the model is going to save the model in your Google Colab. So what you can do is that if you come to this folder icon, you can see that I have precipitation forecast being saved here. So this is very important to save. So one thing that the decision matrix shows us is how well our model perform. As you can see, if we have the number of false negative to be quite less than number of true negative, and number of false positive to be less than number of true positive. So now after we are done with the model, one thing you notice is that if I come to these files and I open this up, so I open precipitation forecast, what we saved now, all our data are in Keras form. We have the model is saved as .pb. So what we need to do is to convert the model to a Tensorflow Lite that can run on a very small microcontroller like the Arduino board. So I'm going to be running the next line of code to convert our model from PB to Tensorflow Lite. And this is where we have our converter, tflite.tflite converter, and it's going to get the saved model from precipitation forecast, which is what we saved in the last code that we run, which is this part. So after running the converter, we need to set some parameters to enable our tflite to work. So we need to do some configurations here. So we can just run this, optimize it, and after that we run the converter. So this is going to do the conversion, and now we can write the file. We can write the model to our file. So this has been written. We have precipitation forecast model.tflite. So if I come in here, so we have the tflite model here. So if you want to run your model as a tflite, probably you have something you want to do, or you are running some other Python script and it takes a tflite model, you can just copy the model from here straight. You have to click on this 3 dots and then download the model straight and can use it in your prediction. But we are not going to stop here. Arduino won't be able to take tflite model. We need to convert it to a header, to a C++ like header, a .h header, and that's what we are doing here. So we are going to convert the .tflite to a .h, which is just a header file. So if I run this, it's going to do some Ubuntu update, and then I have my .h model. So now it's done. If I come here, I have the .h model. So our model has been saved instead of a tflite model. It has been saved as a .h model, which is a header file model. So I can just simply come here and then download this. So I can put this in downloads, save. So this is what I'm going to be using in writing my Arduino code. So after training the model, the next thing I want to do is to deploy the model on our Arduino board. And to do that, I'm going to be using the online version of the Arduino IDE. You can just open it up. We already did this in the setting up of the tutorials, how to set up your Arduino cloud. You can just go to arduino.cc, and then to go to the cloud, I can click on this cloud icon here. So if you do not have an account, this is time for you to create an account with Arduino Cloud. So I already have an account. So I've just come to sketches. I prepared the script, the code that we are going to be using for this tutorial, and it's here. So we're going to be using this. So now I'm here to plug in my Arduino board. So the first thing I want to do is to plug in my Arduino board. And now I'll bring up my second camera. I'll bring up my camera feed. So this is my Arduino board. So what I'll just do is to plug it in. So once I'm done plugging this in, we should see it reflect in our Arduino IDE online. You can see that it's no more showing the X icon here, meaning that our board has been connected to the Arduino cloud. So the first thing we want to do is to include the model.h file that we downloaded into the script. And to do this, we simply come to this option and click on this plus. And then it asks us how do we want to input our file. We can just select import file. And then you have to select the .h file that you just downloaded, which is in downloads model.h. I'll click on this, open. So with this, I can now use this code. So the first thing we see that happens in the code is that model.h is being imported. So if you don't have this imported into your Arduino IDE, this line is going to throw an error. And then we have Tensorflow Lite at work. We are including everything I want to include as regarding Tensorflow Lite. So yeah, we are setting up the number of hours for it to take data before it make the next prediction. So what is important here is what we have here, the T min, H min, T standard deviation, H standard deviation. If you go back to our Colab, we actually printed this out to be copied for later use, which is what I was mentioning the other time. I'll just go to where they are and then copy it. So yeah, we have our temperature. So this is the main of the temperature. I'll just copy this and paste it in my Arduino. So temperature mean, I've changed what is there. Again, I'm going to copy H main, T main, and H STD. So with this part is done. And everything other thing that we have happening in the code is just how we can make our inference using the Arduino board. So if you scroll down here, we can see where the modules are being imported, which are the sensor that we're going to be using. We are using the LPS, this particular module. So what we need to use is the temperature and humidity sensor data that we have on the Arduino board. But let me bring up my camera feed. So there's a problem here. Most of the Arduino board that we have, most of the Arduino 93 BLE Sense board are Lite edition. So what happens to Lite is that it doesn't come with a temperature and humidity sensor, unlike the other version. And from what I read online, it's like you can't come across the normal version again. The only thing that is available now is the Lite mode. So you can see to check whether your Arduino board is Lite or not. It's going to be written there. So you can see we have the LTE written here. So the LTE is written Arduino 93 BLE Sense LTE. What we have just over here. So if yours is Lite also, mean that it doesn't come with a temperature and humidity sensor. So don't try to use it, it's not going to work. But one thing we can do is that we can use the barometer, that's the pressure sensor, to read the temperature. But we can't use that to read the humidity. So what you can do is that you can connect an external humidity sensor like the DHT to read the humidity value. But you can read the temperature using the barometer sensor on the board. So to do this, you have to import the barometer, which is LPS 22HB, and I'm just setting a function here, defining a function to read temperature, and I'm defining a constant here as humidity. So in case you have an humidity sensor plugged, so you don't have to set this as a constant. So after that, we are just checking if everything initializes very well. And this part is also very important. Though we are not using pressure, but it's very important that we declare this for us to be able to use the temperature options for the barometer. So you have to be reading the pressure before you can read the temperature, unless the temperature is going to be 0 at all times. So make sure you are reading the barometer first. That's you are reading the pressure before you read the temperature of what we are doing here. Even though this will not be used. As I mentioned, this is not doing anything, but it's necessary for the temperature. So once we are done with that and everything is done, we can just check through of what is happening here. After taking our data, we are going to normalize it using C-score. Just like we did while training the model. After normalizing it, we are going to pass it into our model. So once we pass it, we're able to make inference using this particular block of code. And then we can predict whether it's going to rain or not. So once you are done with this, everything is working fine. You can click on verify. Let me bring up my camera view. So the code is done verifying, mean everything works fine. So I can then upload it to my board. So once the code is done uploading, we can just open the serial monitor to check this out. So opening the serial monitor. So don't forget, one particular thing is lacking in this setup. We do not have a humidity sensor. We are just using a constant value of 77. So all the humidity is going to be, all the humidity you'll be seeing will be 77%. And we have the temperature that is being read using the pressure sensor to be 34.43, then 34.45. Humidity is still the same because it's set as a constant. And then it says no, it does not rain. So due to this nature of temperature and humidity that we have, so this might not be the perfect prediction due to having a constant humidity, but you get the gist, it works. So that's how it works. That's how you can make your prediction. You can make a simple prediction whether it's going to rain or not based on your temperature and humidity. So one way you can just easily work around this is to get an external humidity sensor, maybe using a DST11 or DST22. Everything is going to work just fine. So thanks so much, and that's this for this tutorial. I'm going to be dropping the link to the script, both the Arduino script and the Colab script, using the description below. Don't forget, if you find this tutorial useful, to give it a thumbs up, a like, and again, please, if you have not subscribed to this channel, kindly do so by clicking on the subscription button below. I really appreciate it. Don't forget to subscribe. Thanks so much. So that's it for this tutorial. That's it for this tutorial, guys. In next tutorial, I'm going to be looking at another thing on TinyML before we finish and round off this tutorial series on TinyML. If you have been finding it useful since the beginning of this series, don't forget to share with anyone that might need it. And if you find yourself lost at any point, you can easily go back to the beginning and still watch from the beginning of the tutorial. So thanks so much, and I'll see you guys in the next tutorial.